This is the 31st LeetCode challenge, and it is called Next Permutation. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, for array 1, 2, 3, the following are all the permutations of array 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. More formally, if all the permutations of the array are sorted in one container according to the lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such arrangement is not possible, the array must be arranged as the lowest possible order, sorted in ascending order. So if you have 1, 2, 3, the next is 1, 3, 2, as that's the next one greater than this. 2, 3, 1 is 3, 1, 2. 3, 2, 1 is 1, 2, 3, because 3 to 1 is the greatest possible sorting of that array. Okay, so yeah, we went over this. And then if it's 1, 1, 5, it is 1, 5, 1. Okay, let's get started. Okay, so there are some things that we need to think of for this. So we need to find out, to begin with, if it's the greatest possible number, then we just create the lowest possible number. If, let's say, all the numbers are the exact same, we just keep it as it is. And then it's the actual figuring out what the next highest number is. Okay, so first thing we'll do is check to see if all the numbers are the exact same. So we'll do a dictionary for this. This will be int numbers equals new for each int num in nums if it doesn't contain, then num equals 0, and then numbers plus plus. Then from that we do if numbers.count equals, we'll do less than or equal to 1, we will return, but I also want to, for the sake of testing, put this in here. We'll do one number output, and so if it's not that, we go to here. Then we want to check to see if it's the highest possible. What's the best way to do that? So we'll do a function for it. Private int array get greatest permutation. This will be, we'll pass in the dictionary of numbers. This is going to be kind of inefficient because we need to figure out what the length of the array is and then what the lowest number is, but we're using a dictionary. So we'll do int total equals 0. We'll then do int current. Actually, what numbers can be done? So 0 to 100. Okay. I'll just notice array length can be 1, so we also need to put a check for that. If nums.length equals 1, we will do this. Okay, then back to here, current equals -1. Actually, this will be a key value of int, and this will be new key value pair int of -1, 0. But initially, we'll be trying to get the total from that, so we'll do for each var pair in numbers total plus equals pair dot value total. Okay, so once we have total, we'll have int array highest, no, that's greatest, equals new int array total. Actually, just to make sure I don't affect the region one. Okay, what I'm trying to do is set up copy dictionary values. Actually, we just need copy dictionary. Okay, we'll just do that. I'm going to use nums copy for this. Okay, so now we'll do for each var pair in numbers. No, this add-on will be while nums copy dot count is greater than 0. we'll put this current one, actually yeah, we'll keep that there. Oh yeah, we also want int index here, just so we know which part we're working on. Then we will go through here, we want it to be the lowest value that's closest to this. No, we don't need that at all. Int lowest equals int max value if pair dot key is less than lowest equals pair key. Then we go out of here. We will then do for, well no, this is greatest, we want, okay, change this around. So highest, if it's greater than highest equals key, and want this to be min value. So for int I equals 0, I is less than nums copy highest I plus plus, and this will be greatest index equals highest. Yep, then index plus plus. Then we go to here, nums copy dot remove highest, and then this returns greatest. Oh, return greatest. Okay, I just want to make sure this works to begin with, so we'll go here and we'll do console dot write line. So we're doing greatest permutation, and this takes the numbers dictionary created. Then just for the sake of output, we'll do join like that. So just to see if this actually works, which it didn't. Key not found. What value were we using for that? So highest is 3. Nums copy has 1 and 2. Okay, what are numbers? So that should have been fine, I would have thought. Let's go down to here. So nums copy 3, numbers, yep, 3. Greatest or highest is 3. Okay, that works as expected. That gets removed. Yep, so go to here, highest, min value. I forgot to do numbers copy here. So save that, rerun it. Okay, cool, we've got the highest one working. And then we're going to do the same thing for lowest, which is, for the sake of being quick, I'm just going to copy and paste all this down here. Name it to lowest. This will do essentially the same thing, but we will change that to lowest, change this to low. So low, low, low. This is less than. This needs to be max value, low, low. Okay, and then we'll just do the same thing up here, testing to see if it works. Get lowest. Run that. Yep, 3 to 1, then 1 2 3. Yep, 5 on 1. Yep, okay, that worked. So what we will do is var greatest permutation equals greatest, and we'll do bool is greatest equals true, and we'll do for int I equals 0, I is less than numbers dot, does that count? No, it should be nums dot length, then I plus plus if nums I does not equal is greatest I, greatest permutation, then is greatest equals false, and then break. And then what we'll do down here, if is greatest nums equals get lowest permutation with numbers, we then do highest to lowest output and return. So one of the outputs should run that, so let's see if it does. Okay, we can see here highest to lowest output 1 2 3, and that was this one for 3 2 1, expected output 1 2 3. So that is working. So now that we've done that, it's time for actually handling this, where we're going to be increasing to the next highest permutation. So I think the way to do this is by looking at the greatest number that's contained in this array and finding the position of that. If it's not in index 0, we then move that number to the left by... No, that's not how you do it. Okay, let's look at these number examples here. So with this one, it's in the very last position, so we increase it to this one. Essentially, they just swap positions. With this one, we move this one up. Okay, so we go from right to left, so we can't increase this one by default, so the next best thing is moving that up one. So if this is the... Okay, so we look at this number. If this is greater than this number, it then moves up. With this one, if this one is greater than this, which is not, it doesn't move up. But if this one's greater than this, it does move up. Okay, I think that's how you would actually do it. I was thinking it would be something else. So we'll do private int here, increment permutation. Let's take it numbers, and we'll do for int I equals, I'll just shorten this to nums dot length minus 1. I is greater than, I think this has to be greater than 0, because I can't do the last number, I don't think. Yeah, okay, let's keep it as that for now. Now we'll do I minus minus. And we will do if nums I, actually do it like this, so I minus 1, so that's the number on the left. If the number on the left is less than the number on the right, int temp equals this equals this, and this equals temp. Then return nums. I'm not sure if that is how it should be done. Wait, let's move this one up to here, just so we can look at it more closely. So let's now try that. I'm not sure if that was all that had to be done, but I need to see the output. Output 132. Wait. Okay, I've done something wrong here. What was that? Input 132. Oh, that was from here. Oh, that was meant to be 123. Wait. How did that happen? Oh, because it's the same reference, it's changing the number, so that looks like it's actually working. But to get the proper output, I need to do this. So we need to print it first, and then we run that, because we were losing that. Yeah, okay, 123, output was 132, and that seems to be working as expected, which is cool. Okay, so I am going to grab all this code and then copy that into LeetCode. So this function, that function, and we will copy up to here. We will paste that in here. Run on the test ones just to make sure. Okay, that didn't work. 3 to 1. It outputted 3 to 1. But when I run it, it gets 1 2 3. Oh, it's probably because I may have forgot to actually change it. So that is highest to lowest. Okay, maybe the way I've done this isn't how it should be. Okay, we are also going to be passing the array into it. Okay, that's only for the lowest one which needs to be done. And that will be int this nums. So remove that, run that to make sure it works. Visual Studio is messing up and not running it, so I'm just going to test it in LeetCode by copying it all and putting it in. So run the test on that. Okay, it worked. 3 cases are working here, so let's submit and hopefully it works as expected. Okay, we got a wrong answer. So we got 132. Okay, I didn't think of that. Although I'm surprised it took that many cases until it came across that. So, that complicates it. So, currently we're doing if, say we got, if This one is greater than this. No. This one greater than this. Yes. We're swapping them. But what we should be doing is, if any of these are less than this, then we swap those, and then that, I think. Well, we'll add this to use cases, and we'll add it into here. So 132 should be 213. So the problem is in here. If it's less than, this actually makes it a bit more complicated. So that number. Okay, so we need to do bool earlier has lower is false, and what we do is for int j equals I plus 1, j is less than nums length minus 1, j plus plus. And what we do is, if nums I minus 1 is less than nums j, we then do earliest is true and break. And for this is if there isn't one that's earlier, then we just run this as normal. But if there is one that's earlier, okay, let's do int earlier index equals -1 equals j. So do int temp equals nums1. I think we're then doing nums I equals nums j. I think we then do this again. Oh wait, this is meant to be -1. Okay, early index. So we're iterating up again. We start off this time at I. And what we do here is int temp 2 equals nums j. So actually, why don't we just do it from up here? Int lowest equals int 33 max. Int lowest index equals -1. And we can just do if nums I is less than lowest nums I, lowest index I, and then we do, instead of this, if nums minus I is greater than, actually this should be if nums I is greater than lowest, then lowest index goes here. Okay, so we've got the initial one. If it's, no, this should be if nums I is less than or equal to, then you just do it as normal, the normal swap. So if the current I number is greater than the previous one swaps up and we move it down. So int temp, we're getting the lowest one we're overriding. We are replacing that with this. Then in here, doing this, nums j equals temp, then temp equals temp2. I think that's how it'll work. You know what, let's just run this and see if that did anything. Okay, so 132. That didn't work. Okay, we're gonna have to go line by line for this first one. Let's see what's going on. Okay, go here. There we go. So initializing those values. If nums is less than lowest, which should be 2 next to, yep. So this won't be lower, so let's carry on. Found the mistake. This should be up here. Now let's run it. Ooh, but that didn't work. Okay, we'll go down to here and see what happened in that loop. So temp, we're getting the current value, which will be 1. Overriding that with 2. Then go into here, temp2 will be 3. We then make that 1. Okay. Wait, no, I shouldn't have exited from that. Let's go back into that. Okay, then J will be 2. But wait, why did I exit? Ah, it shouldn't be less. Okay, that was the problem. Let's run it again. And there we go, got the correct output. So let's copy this function and put it back into LeetCode, and hopefully that will be the only problem that's going to happen. So put that in there. Run on the test ones, and that worked. So now let's submit. Not the wrong answer. Is that the one we just had? Okay. That is... I didn't think of that. Okay, I need to take a look at this one again. So that was 132. So I forgot to do a check to see if this is greater than this one, but less than this. Okay, that's a mistake I made there. So, go back to here, wherever that is. So if nums is less than or equal to lowest, so we do this, we know that one we're working on is greater than this one, so we want to swap. Okay, so if nums I is the lowest, or nums -1 is greater than or equal to lowest. So I'll chuck that into here and run on the test one, just to make sure. Okay, that didn't work. I-1, that's what I forgot. Okay, still wrong. So 2, 3, 1. Okay, no, so we need to get rid of this and this. Okay, so we need to find the lowest one. Lowest that is the closest to nums -1, I-1. Okay, so I think we get rid of these, and we'll do it in here. Int lowest equals int max, int lowest index equals -1. And what we will do is for int j equals I+1, j is less than nums length, j++, if nums j is less than lowest and greater than nums I-1, nums j is greater than I-1, then lowest, actually this should be lowest or equal to, lowest equals nums j and lowest index equals j. Okay, we then do that, and okay, I'm going to add this to the test because I want to see what it does. Okay, so if you run that now, does that work as expected? So it still did 3, 2, 1, so that was just swapping these two. So if nums 1 is, okay, so how do we do this? We want this, if it's not this, if it's less than or equal to lowest. If this, I want to add another test case to this. So let's do 4, 5, 6, 7 here. What's that meant to be? And what do we make? Okay, I've been approaching this completely wrong. We need, okay, I need to change back to this. Int lowest equals int max, and we'll do same thing, int lowest index equals -1. So change that again. Do the same thing as before, which was if no, that goes back out to here, and this goes back up here. So if nums I is less than lowest equals nums I, lowest index equals I. Okay, so we got that. Okay, remove this. And what we need to do, we'll create bool current lower equals, we'll do this, interval previous lower equals this. And looking at this, how did it do that? So lowest would be I. We'd first do this and check no. We'll then go to here. If this is that, no. If this is greater than this, then yes. We would then want to switch these two, but then switch those two. Okay, well, let's make another one of this. What if it is... So these are swapped. What happens? Okay, it's still just those two. Let's change that then. What if that's a 6? Okay. I think I might have it. So this is the lowest. Don't swap those two because this is greater than this. We get to here. This is less than this. And then this is less than this. So we want to swap those two because this is less than this. But then we've got 6 and 1. And then we swap those two because... So the first swap is this is less than this. Then for now on is if this one is greater than this, we swap. But then for this one, we got 6, 5, 7, 6. So this is less than this, but then this is greater than this. So this is less than this, those two swap. This is less than this, so they also swap. Wait, no. So 2, 3, 4, 6, 6, 5, 7. 2, 3, 3, 4. Okay, so when you encounter one which is less than the other, you then want to find the smallest one, then that one goes to here, and then you go highest to lowest for there. Okay. Okay, so if current is lower, do that, because that is the starting point. I think we need to get rid of this one here, because in this case, I is lowest. No, we don't need to keep track of this at all, don't think. Okay. Yeah, I'm gonna have to kind of change all this. So int num temp, keep that. We then need to go for int next num equals, we'll just set this as temp, and then int next num index equals I minus 1. Wait. Oh, I keep confusing myself for this. So temp, no, this should be -1. Next num is temp, and next num index I minus 1. And this should be, we'll just do max value and then -1. So for int j equals 0, j is less than num's the length, j plus plus. Actually, should be this. I think this is how I would have to draw int k equals 0, k, int k equals 0, j plus 1, k is less than num's length, this is num's length minus 1, k is plus plus, and we keep this temp value, and we do if num's k is less than next num, then next num equals is less than next num, and temp is greater than nums k, is less than nums k. No. Okay, how does the swapping work again? So the next highest number is this one moving up to here. So start off with these two. This is less than this, but we want to see which one is the lowest one next. So this one would be moved up. Okay, so if this number is lower than next num, but temp is also lower than next num, or also lower than num, then it does it. Okay, I think that is what it is. Then what we can do, if next num equals temp plus 1, I think we can break. Or is it the one furthest on the right that we want? Okay, I'm going to change this number. Let's make this like that. Let's see what it does. Okay, so it wants the one all the way at the end. So that means we should remove this. Wait, No, that's not right. So we go to here, this is less than this, and 5, this goes to here. I think we need to do this. We don't need those 2 loops, we just need the first one. So this is the first iteration of it. Okay, double check where 5 went. It did do the first one. No, it didn't. Okay, that actually doesn't matter which one it is. We just replace it. So what we do, we will do nums I minus 1 equals next num. Then we will do nums next num index equals temp. So that is the first swap. Now for the remaining numbers, we need to go from lowest to highest. The reason why it's lowest to highest is because this number represents like 500. 567 is less than 765. So that's why I'm doing it that order. So now it will be, actually change it so it's int swap index equals -1. We'll do if current lower equals I minus 1, and then break. And that's all that this for loop has to be, because currently we've got unnecessary for loops. So bring this back to here. So temp, do that. Swap index +1, and this can be I, and swap index. Then we can do for int I swap index +1. Basically same thing again. And then we'll have int lowest equals 32 max, int lowest index equals -1, then for int j equals I, j less than this, and then j++. And if nums j less than lowest lowest index j. So we do that. Then we do nums I equals, don't need to save the index, just need the number, equals lowest, and then we'll carry on. I have no idea if this is going to work. Let's just run it. Okay, definitely didn't work. Did I forget something? So that worked. That one still worked, which is expected. 132, 231, 31. Somehow forgetting, somehow not swapping that. Okay, let's go line by line. So nums is 231. Current lowest is false. 3 is not lower than 1, so continue. This will be true, because 2 is lower than 1. So we got that index. So swap index should be 0, which it is. So next num is 3. Currently, if 10 plus 1 would break, which is expected. So swap index, next num, which is 3. Num's next index is temp. Okay, so that goes to 2, which is expected. So now we've got 3, 2, 1. Now the 1 and the 2 should swap. So int lowest num j. So that's currently 2. Forgot to put it here. Temp equals nums I. That's why I needed lowest index. Int lowest index equals -1 equals j. Then num j temp. Lowest index, I mean. Okay, hopefully that was the only mistake I made just then. 312, 312, 213, 213, 132, 132. Okay, that looks good. So we are going to copy this function and put it back into LeetCode. Increment permutation, this one. Okay, like that. Run it in the test ones. Hopefully those are all good. Ooh, they were all good. So let's submit, and hopefully that's the last of it. Oh, and that was the last of it. Last of the mistakes that I had made. Not the most efficient in terms of performance, but that's not what my goal is with this. I'm just trying to solve the problems. So that was the 31st LeetCode problem called Next Permutation. If you like this video, make sure to like and subscribe.